Here in circle S, we are asked to solve the value of the unknown measurements for variables x, y, and z. In our given figure, we could also see an inscribed quadrilateral, and it is one of the most important concepts that we could draw here because there is a unique relationship among the angles or interior angles of quadrilateral when it is inscribed in a circle. But first, let us try to determine what does the x, y, and z represents. X here is this angle, specifically an inscribed angle, which intercepts the arc, which measures 70 degrees, and in combination with the arc that measures 120 degrees. For angle y, this is also an inscribed angle, and its intercepted arc is this arc here that is not yet labeled as any variable, and this arc which is labeled as z. And as I have mentioned, z represents this minor arc here, which is part of the or combination of arcs that is intercepted by angle y. Whenever we have an inscribed quadrilateral, the unique relationships that we could draw to the angles or interior angles of a quadrilateral when it is inscribed in a circle is that the opposite angles are supplementary. I'm talking about the measurements of the angle x here and angle y. Since they are the opposite angles of this inscribed quadrilateral inside of in circle S, it should be given that the measurement of angle x is a supplement to the measurement of angle y and vice versa. But before we go to that, let us try to determine first which of the two can be solved first. If we look into y, aside from its relationship to x, what we can draw as part of our computation is that the inscribed angle here is half the measurement of its intercepted arc. But the intercepted arc has no exact measurements, so we cannot solve y. Looking into x, this x here, angle x, or inscribed angle x, is intercepting this arc and this arc, which were given already with measurements. So let us start with the measurement of angle x. Again, since it is an inscribed angle, it should be given that the measurement of this inscribed angle x is 1/2 the measurement of its intercepted arc. You can see the intercepted arc from the endpoint of the side, being the chord, towards the other endpoint here, not just in the middle, but the entire. So it should be 1/2 the combination of the arcs that measure 70 degrees and 120 degrees, because this is the entire arc that is the intercepted arc of angle x. This would mean we can compute for the measurement of angle x as 1/2 of the sum, which is 190 degrees. And half of 90 is the measurement of angle x, which is equivalent to 95 degrees. This is the measurement of angle x here. Going towards the unknown measurement for variable y, as I mentioned earlier, when you have an inscribed quadrilateral, you are just going to look into the relationship among the opposite angles. I'm talking about x and y being opposite angles of the quadrilateral. And it is given by a theorem that they are just supplementary. In short, the measurement of angle x plus the measurement of angle y must be equal to 180 degrees. And since we already have the value for angle x, which is 95, the measurement of angle y is simply 180 degrees less measurement of angle x, which is again already given as, or solved, or computed rather, less 95 degrees. This would mean that the measurement of angle y is just equal to 85 degrees. What we use again here is the concept that whenever you have an inscribed quadrilateral, it should be given that the opposite angles are supplementary. Now for Z, which is an arc, we can refer this one into a relationship of the inscribed angle intercepting it. But we don't have a specific interior angle here or inscribed angle that is intercepting it. What do we have is either angle y, which intercepts that arc together with this arc here, or this angle here, which intercepts the measurement of 120 and includes that unknown measurement. So this is what we are going to use, because what we know, this being the inscribed angle intercepting these two arcs, it means that 100 degrees is just 1/2 the measurement of the entire intercepted arc, which includes 120 degrees and the unknown z. Again, this is just similar to the measurement of angle x earlier, being the inscribed angle, but it's the x that we don't know. Right now, we know the value of the inscribed angle, or the measurement of the inscribed angle. What we don't know is one of its intercepted arc. So by following the same pattern, it should be 100 degrees here, which is the measurement of the inscribed angle, is just half of the sum of its intercepted arc, which ranges from this given 120 degrees and including z. For this, we can multiply both sides by 2, and we could get 200 degrees is equal to 120 degrees plus z, when we multiply both sides by 2. And by just simple mathematical computation, including subtraction property of equality and symmetric property, z, or arc z, is equal to 200 degrees minus 120 degrees, which will give us a result for z, which is 80 degrees. So this is how we solved the values, or the measurements of the unknown variables x, y, and z in this circle S involving inscribed quadrilateral.